Here for chapter 1 is that we're working on statistics and its definition. But it's really pretty important for us to have an idea that statistics is not the same as other kinds of math. So here's math, and here's statistics. And a lot of people have trouble kind of putting their minds around the difference between the two. Let's say I have something that looks like this. If I write 4x plus 1 is equal to 13 on the board, what happens in your mind? And what do you get? Which is what? 3. Now, if I put this same problem up on the board tomorrow, would you get the same answer? The Babylonians were doing problems like this 6,000 years ago. If they did this problem, they would get the same answer. If 6,000 years from now you want to do this problem, you would also get the same answer. This is a standard feature, not a bug, of mathematics, that it's the same all the time. Consider this problem. What is the average purchase amount at Quick Trip? How often does that answer change? Every time. Will it be the same yesterday as it was the day before? No. If someone tells you, I know what the average answer is for Quick Trip for today, is that possible?
No.
Why not?
It's not the end of the day.
It's not the end of the day. People are going to keep buying stuff, and it's going to change. If you ask the question, what is the average Quick Trip purchase amount today? It's impossible for you to know that answer. Because as soon as you figure it out, it's going to change. There is no answer that stays the same for this particular question. Thank you. So in statistics, the numbers are constantly changing. So that means we need to have the ability to understand numbers which constantly change. Now, this question that the Babylonians might have asked, and that we can ask again in 6,000 years, in practical terms, nobody cares about this answer. Nobody cares that x equals 3 is a solution to this problem. It's a trivial thing, and nobody cares about it. How important is this number to Quick Trip? Why is it important?
Profit.
Okay. Right.
Bottom line.
Right. Trends. What's going to happen tomorrow? Is it different than what happened 3 months ago? If you make rib sandwiches free, is that going to change your average? Probably, right? So these kinds of things are very important to a lot of different places. What about sodium levels in patients that have high blood pressure? Well, I'm not a doctor, so I don't know for sure. But there's probably somebody who really cares about those things. But the fact of the matter is they don't know what they are. If I measure your sodium level right now, 15 minutes from now will be different. Because your body is always changing. Your heart rate right now, your blood pressure, they're all over the place. Even your weight. If I weigh you to the nearest gram before you walk in, and when you walk out, it's different. These things are always changing. There's never an exact answer. That's very different from this, but these are the kinds of measurements and numbers that people actually use all the time so that they can actually understand what's going on. So in statistics, there are many times when the answer is maybe so, or it could be, or I think that's most likely to happen. Whereas in math, it's either right or wrong. In statistics, it doesn't have to be like that. It can be a very different kind of experience. And so let's say that you go out to 7 decimal places in a number in statistics. 15 minutes later, that number is different anyway. So it doesn't make sense to go out to 7 decimal places because it's not the right answer in the sense that it's exactly what it's always going to be. It's just not. And so you need to understand relationships between numbers. Numbers by themselves don't tell you what the answer is. You have to understand what the numbers actually mean in order to know what the answer is. And that's very different than what you might call regular mathematics, right? It's just not that way in statistics. So then when we say, well, what else happens when we're doing statistics? There's a lot of other things that happen. One of them is that when we're doing statistics, we need to keep the purpose of the number always in mind. And so I want you to know this, and I'm going to try to ask you every chance I get. What is the purpose of statistics? The purpose of statistics is to make data-driven decisions. So that we want to use the numbers and the measurements that we have in order to make decisions about things. Well, what exactly do we mean by that? Generally, this is what we mean. We want to know the trends. And by understanding the trends that are in a data set, we want to find out what to expect. If a doctor says to you, you should take some Tylenol for your pain, the doctor does not actually know that it's going to work. The doctor doesn't know if you are allergic to Tylenol, and it might make you a lot worse. The doctor doesn't know that. But the doctor is going with what most of the time works for most people. Your individual case might be different, but they're going with what they expect to happen. When people take Tylenol, the thing they mostly expect is that they feel better, they have less pain. And statistics tells them that that's very common. And so then that's why they say that's a thing for you to do. In order for us to understand what to expect, there's a certain number that is very often used in statistics. And that is that unusual events occur less than 5% of the time. This is a statement that's traditional in statistics, but it's also something that has some psychology behind it. If you talk to people and say, okay, here's something that happened, would you consider this an unusual event? 5% is a decent number to use. Traditionally, it's the number, but we can have some differences with regards to that. But as a rule of thumb, and as something that we use a lot, if we say it happens less than 5% of the time, we consider that to be unusual. That gives rise to a particular thing. Less than 5%, quote unquote, no, we don't expect that to happen. more than 95%, yes, we do expect that to happen, in quotation marks. From 5% to 95%, maybe. This was what happened in the most recent presidential election. The websites that I was looking at had Donald Trump anywhere from 15 to maybe 30% possible of winning. And those websites got a lot of pushback. There are a lot of people who said, how can you even say that it's possible for Donald Trump to win? Well, the fact of the matter is there were a lot of undecided voters, and there were a lot of factors that were still happening all the way up to the election. We'll probably talk about this more as we look at more things. But certain things needed to happen in certain locations, one of which was Wisconsin. The person who was in charge of Donald Trump's Facebook campaign had certain behaviors on Facebook that they had noticed for certain people, and they put ads into those people's Facebook feeds that had certain opinions that those people were interested in. And the people who made their decision during the last week of the campaign took Wisconsin from voting for Clinton to voting for Trump. So to say that you know something's going to happen because it's 70% chance or 80% chance of happening is just not true. Or if you say, oh, it's like a 10 or a 20% chance, to say, well, that means it's impossible. Not at all. Anything that's between 5 and 95% could happen. Now we might have a little element of surprise if something that's 8% happens. And we might say, oh, well, if it's 85%, then that is most likely to happen. Yes, it is. But you should not be surprised if it doesn't. And there were a lot of people who were very surprised by the fact that Trump actually won. Now, if you ask the question, was there Russian involvement? Probably. Were there things about the FBI coming out and saying Hillary has emails? Yes. But the fact of the matter is the person in charge of the Trump campaign had certain groups of people that they knew would be influenced by certain opinions at the very end of the campaign, and they sent those ads out, and the numbers changed in the last week of the campaign. So to say that it's all because of the Russians doesn't necessarily seem realistic. Now, there are people out there, statistics people, who say that the Russians had something to do with what happened. I don't know the answer. But I do know that a lot of people, if they see something that's like a 10 or a 20% chance, they think it's not going to happen, but that's really not true. Less than 5% is where we draw the line generally to say that's not expected to happen. We are surprised by things that happen less than 5%. And we're not really going to think something is going to happen until it's more than 95%. And those are the ways that we make those kinds of decisions. Now, this being true, this being said, having the idea of making a decision based on this kind of information, this is something that a lot of businesses believe in. They think that if you have numbers, then you can prove something's going to happen, then that's going to tell you what to do. Unfortunately, they are wrong when they say that. There's no way for you to actually make these kinds of things happen strictly on the basis of statistics. Statistics alone does not tell you what to do. You have to have experience. You have to have the ability to interpret things, not simply the numbers by themselves. My wife currently has her own business. She makes custom quilts and weighted blankets and other stuff. But she used to work for a company that was a multinational company, and it sold things to other businesses. And they had a particular program in place where they said, if somebody comes into the store, we want you to give them a customer survey. And if you give enough people these customer surveys and you have a high enough level on those customer surveys, we will give your location a bonus. Now, if they had actually known what was going on, they would have said, well, the fact that you're doing this in the middle of winter in Wisconsin compared to like California or someplace like that, people are not going to be necessarily positively attitude, right? When they just had to scrape off their car for 10 minutes, go through the streets where people were trying to run into them all the time. They finally make it to the store and they have to slip and slide on their way into the place. They're not going to give you a necessarily positive recommendation. But it's not have anything to do with the store. It can have everything to do with the climate. Or let's just say you had a certain location and they had flooding. And people had to clean out their basements. And then they had to come into the store. They're not going to be happy regardless. And so if you say, oh, can you please fill out this survey? They're not going to feel very good. And so when that store gets a low rating, it means nothing for your business. It's not reasonable to base the performance of somebody's money. Are you going to pay them more or are you not, based on customer surveys? It doesn't make sense to do that. But a lot of companies are trying to make that happen. The reason why is because they're lazy. They don't want to actually talk to their employees. They don't want to actually talk to their customers. They think that if they just have a survey where people fill in little boxes, it's going to tell them how to run their business. That's wrong, and it doesn't work. But there are a lot of companies who think it's a great idea. And so if you're ever in that situation where you have an employer that's saying, well, your customer service things don't look very good, so therefore you must be a bad employee, send them to me, and I will tell them that doesn't work. You're not doing the right thing by just using these surveys to try and figure out what's going wrong or what's going right. You have to actually talk to people. Numbers by themselves don't tell you what's actually happening. So that's my little soapbox. Because there was a manager, the manager of that particular store, they would not give that manager a promotion because they didn't have enough customer service surveys to justify it, according to their ideas. Crazy. Anyway, all right. So when we're talking about statistics, these are some of the things, pardon me, that you need to be aware of. What is the purpose of statistics? How does it work? Now, when we say what is statistics, what does it do actually? We have three different things. We collect, we describe, and we decide using data. So these are the three things that happen in statistics. We have to collect the data, then we have to have some way to describe the data, and then we have to have some way to actually decide what it means, right? Now, in that process of making it happen, specifically for this class, we're not going to spend a lot of time on the collection part. That's just going to be this first little part of what we're doing. We are going to spend more time on the description, which is going to include graphs and numbers. But most of the course is going to be how do you use these things to decide something. Now, so this is, if you want to say the definition of statistics, this is the purpose of statistics. You also need to know the process of statistics. What is the process of statistics? The process of statistics is where we use sample data to understand a population. Most of the time, we don't have all of the numbers for everybody. And even if we did, it might be hard for us to use all the numbers. For example, if we wanted to know something about opinions at Western, would it make sense for us to try to have a phone conversation with every student that is registered at Western? Well, we could, right? We could try. Probably just about everybody has a phone number, so we could at least try to call them all and find out what they think. But it probably still wouldn't work. By the time we got through calling everybody, their phone numbers would have changed, or they would have no longer be registered, or other people would have started to register. And so it would be impossible for us to really get a survey of every student who came to Western. However, there might be, and I think there are, ways in which we could take a smaller group of people and have that smaller group still be enough to get information that we need. And so the question is, how does that work? Can we get it to work? Are we able to make good decisions based on smaller sets, not necessarily talking to everyone or having all of the data? Can we use a smaller group to understand something about the larger group? And the answer is, yeah, maybe, kind of, most times, depending on, okay? So we want to know how that works. We want to understand the mathematics behind it, but we also need to understand a lot of other things. And that's in this whole idea of collecting. When we're collecting things in statistics, there are a lot of different factors, a lot of different issues that can mess up our data, make things that they don't actually work, and we need to understand those kinds of problems. So what I want to work at then for maybe a bit longer here is to try and figure out what are the things and the problems and the issues involved in collecting data. So does anybody have any comments or questions about anything so far? All right. So what happens when we collect data? What we run into is a relatively common problem if we collect data. Convenience does not equal good information. Some people have said, if it's easy to get your data, you're probably doing it wrong. A lot of times people will, in their attempts to get information about something, they will use a convenience sample. They'll just pick whatever's nearest to them. Let's take an example from here. If I wanted to know something about the programs that are popular here at Western, would it make sense for me to ask you people here in this classroom what programs you are in? Would that tell me something about everybody at Western? No, because you are in this classroom for specific reasons. You're not in welding because it's not a welding class. You're not in business, maybe, because it's not a business class. And so just because it's easy for me to ask you questions doesn't mean I'm going to get good information about them. Let's take another example. Let's say that we want to know how people feel about parking in La Crosse. Let's say I go down to the post office at noon every day for 3 days. Is that going to be a good place for me to get good information about opinions in the cross? Would that make sense?
Yes and no.
Okay, why not?
Yes, because that type of parking area at that particular time for the people that you gather the information would agree with you that it'd be atrocious.
Okay, so then if you want that particular opinion, maybe,
Right.
yeah, but if I want opinions in general, why would that not work?
Because that would be one specific time frame where it is atrocious.
Okay. So what if I pick different time frames and I still go to the post office?
That would be better, but you'd still need like the broader lacrosse area because it's just really tight down there.
Okay. Does everybody go to the post office? No.
Amazon.
Yeah. I haven't been to the post office in many months. Some people would go there regularly because they have a post office box. So if somebody goes to the post office in order to get opinions, then the fact that they went to a specific location is going to affect their results. Now, there's another problem that happens. Let's say that you want to call people on the phone to find out how they are going to vote. Is that going to work if I call people on the phone to find out how they vote? Why not?
Most people, when they find out that it's somebody like that, they just hang up right away.
Okay, people don't want that kind of stuff, right? Now, this happened to me not too long ago. On the phone, the caller ID said that it was my wife and that it was the number they were calling was on the caller ID. So that was really kind of spooky. So I answered it because I was just kind of confused. How could my wife be calling me from this same number? And it was, oh, this is Louise. Your credit card often needs to have an upgrade, and it was recording, right? So somebody was spamming me using that kind of stuff. And the fact of the matter is, people don't respond to surveys if they know it's a survey. They don't want to be bothered. Well, that's something called non-response bias. What that means is people who do not respond for your information, they have opinions, but you don't know what they are because they didn't respond. And so then you're like, well, I would like to know what people think, but they're not responding. So I don't know. So that's a problem. There are many other things that create problems when we're dealing with convenience samples. But we're going to talk about some other things. Something called a confounding variable. What happens if you have a confounding variable? The basic idea, it's something that affects the results but you don't allow for it. For example, let's say you want to find out the color of cars in lacrosse. And so you go out there and you're saying, well, I'm going to put them into different categories and I'm going to just put check marks, the different colors of cars. And I'm just going to sit here on the corner and watch them go by. Well, what if there's a company that's 2 blocks away and all of their cars are white? And So this company has people that are going back and forth, and they're always using these white cars, and they're 2 blocks away from where you happen to be sitting. You don't know that necessarily, and yet it's going to change your results. And so you come back and say, wow, white is a really popular color. That might not be. And so whenever you're collecting data, you don't actually know if there are things out there that might be affecting your data, because it's what they call, I think Donald Rumsfeld said this, the unknown unknowns. Things that you don't know are affecting your data, and you don't know what they are, so you don't know what the effects are. So you can't, again, when we're talking about doing statistics then, and you're trying to collect data in order to figure something out, is it true that if somebody takes this medication, that their sodium level will go down? Well, just because you give it to them and it goes down doesn't mean necessarily that that's what happened. It might be that you just happen to find a lot of people who are sensitive to your stuff. So then we need to, whenever we're doing the data collection process, we need to try and figure out what are things that will affect the results, and how would I take those things into account. For example, there's been a huge argument about whether weight loss and health are actually connected to each other, okay? Is it healthy for people to have a certain body mass index? Is that how you figure out whether somebody's healthy or not? And it's like, well, seems like it, so let's just go with that, all right? But is it real health, or is it just a convenient thing? We know a lot of people's height and weight, we can figure their BMI, so let's just see if it works. And maybe it works for a lot of people, but maybe there's a lot of other things that we need to be measuring. So just to have something that's easy means that we're maybe not taking everything into account that we need to. Now, we'll talk about some more problems as we go through here. But one concept that's a standard method of collection is to use random chance. There are a number of times in mathematics where we can use a specific formula to understand things based on the idea of random chance. But then the question is, what do we mean by random? The definition of random, and we'll talk much more about this later, is that every possible collection is equally likely. So if we say, I have 30 people in the room, how many different random samples of 6 would I be able to have? I would have to make a list of all the possible combinations of 6 people that I could have. That would tell me how many random possibilities there are. So let's say I want to measure something about Western students. Well, then I would want to have a list of all the Western students, and then I need to have some way of treating all those students equally likely, and then picking out however many I need. Now, there are computer programs to do that. Generally, we say things like a raffle. If you have a bag of all these tickets and you shake it up and you just pick one out, that's probably pretty random. Everything's equally likely to happen. But if you don't do this, then there's a tendency for some kind of a thing to mess up your results. And it's really hard sometimes to get a random sample of every possible person that's out there. So this is like the thing we would like to have happen, but it doesn't always happen, and we just kind of hope that it's close enough to what we want. All right, so then there are a couple of other things that happen when we do data collection. It's important for you to understand the difference between experiment versus observation. If you're doing an experiment, you're actually causing a change. You're making something happen, as opposed to observation, where you're just observing. Let's say, for example, I want to know if cranberry juice helps people in assisted living to have better health outcomes. How would I make that happen? If I'm doing an experiment, I would give them cranberry juice. I would say, sit down, drink the cranberry juice. Well, they don't have to sit down, I suppose. Here, drink the cranberry juice. And then I would have other people who would not drink the cranberry juice. So I'd have the people I cause to drink, the other people I don't, and I would compare the difference. If I was just doing an observational study, then I would have to have some way to observe all the people who did drink cranberry juice versus those who did not. So I'd have to maybe write down everything that they ever ate or drank. And if they had cranberry sauce, maybe it would mess things up. So no cranberry sauce either. But I would want, in the observational thing, I'd have to make sure I kept track of everything. But in the experimental, I actually give them the juice and other people don't get it. And then I compare the results. But that can create a problem. Okay? You might have heard of this, the placebo effect. What is the placebo effect? The placebo effect is that you have a situation where you give someone something, but it doesn't actually contain any kind of effect. For example, they talk about a sugar pill. So you give somebody a pill that has the medicine in it, you give somebody else a pill, but they don't have any medicine in it. That's a placebo. The placebo effect, however, is that people feel better when they get the pill that has nothing in it. The placebo effect is that if somebody believes they're getting treated, they feel better. And in fact, in the United States, it's specific to this country, there are so many people who feel good when they just talk to someone about their problems that it's very hard for companies to find new medications for pain. You have some kind of a chemical and you think it helps people with their pain. But what you find out is that no matter what you do, no matter what you give them, they feel better if they have somebody to talk to about their pain, whether you actually have a medicine in the pain or not. The effect of being treated is bigger than the effect of the actual chemicals in the thing. And so why spend millions of dollars creating new chemicals? What we should maybe do is spend millions of dollars talking to people about their stuff, because that actually works better than the chemicals. All right, so if you have somebody around you that has stuff, you should talk to them, because then that's probably better than any doctor with any chemical can do, because people care more about people than they do about chemicals. Anyway, that's not always true, but it's something. The placebo effect is important. I'm not saying that doctors are bad or chemicals are wrong. I'm just saying that people actually have a lot of power in their human relationships, maybe even more than the medicines.
There's an opposite effect of that too.
There is.
Yeah,
Yes.
the nocebo.
Ah.
The nocebo effect basically states that if you tell somebody they're going to die because they have cancer and you find out they don't, they actually believe they have the cancer and they will develop that negativity.
Yep. And it's also true that there are people, if you tell them that they're going to be treated for something, then they will develop side effects because they're being treated. It's like, okay, everybody sit down. I'm going to give everybody everything. And you give them a sugar pill and they say, oh man, I feel dizzy. I feel really dizzy right now. Well, why? Well, I took this pill. There must be something in it. No, there isn't. Well, there's got to be because I feel dizzy. And so people will create things out of their own mind because they're being treated. And it could be either positive or negative. What about asking middle schoolers about their drug habits? If you ask a middle schooler if they've used LSD, what will they say?
No.
Why would they say no?
Because they don't want to get in trouble.
They don't want to get in trouble.
Yeah.
But I happen to know a couple of middle schoolers, and they would say yes. Because they're middle schoolers, and they want to mess with people. And so they'll say, oh yeah, I do a lot of drugs. How many boxes are there? I do them all. And the research has been done on both sides where they would have a particular school and they say, wow, this school seems to have a drug problem. And then they would fly somebody in from Pennsylvania and say, I'm from Pennsylvania. I don't care. Tell me about your drug situation. I want to know exactly what's going on. Oh, I lied. So there's not a drug problem. Well, but there's a problem with middle schoolers, but we all know that, I think. That middle schoolers are problems, just like the rest of us. But they don't hide it as well as adults. Adults are better at hiding their problems. Middle schoolers are kind of out there. So there are other things that happen. Let's say that a company decides to fire a third of all their workers and cut everybody's pay by 20%. 2 weeks later, they ask them about the recreation facilities. They send out a survey. Nobody likes the recreation facilities, but that's not the issue. The issue is not the recreation. It has nothing to do with that. It's the actual things that are happening in the business that really do matter to people that they don't like. Just like the weather in Wisconsin can change people's customer surveys. Now, there is also, besides the placebo effect and the nocebo effect and other positive and negative things, positive and negative demand things, there's also something called double-blind testing. So if you say to somebody who's in the nursing home, well, we're going to try to find out the effects of you drinking cranberry juice. And they drink cranberry juice. And then you say to the other people who are in the survey, well, we're trying to find out what are the effects of cranberry juice, but we're not going to give you any. Then it's like, well, I guess it's not going to help me then, right? Whereas the people who get the cranberry juice are like, oh, yes, I know that that's good. It's cranberry juice. But what if you give somebody water versus cranberry juice? Is that going to be maybe a more precise thing, right? It's water versus cranberry juice. So it's not just the liquid that's the difference. But how do you know that they're just not responding to the fact that it's red? So maybe you put food coloring in the thing and it's red, and the other one, it's not. It's juice. But then, if the person who is giving the juice to them, if they know that it's real, then they treat the person differently than if they don't. So if you have somebody who's giving the treatment and they know it's real treatment versus they know it's fake, that's going to change the effect. So it has to be a situation where the person who's receiving it doesn't know if it's real or fake. And the person who's giving it, they don't know if it's real or fake. That's what double blind means. The person giving it, they don't know if it's real or not. The person receiving it, they don't know if it's real or not. So then, that's double blind. Kind of interesting recently. They had a study done on knee surgery. So what they did was they said to people, okay, your knees are giving you trouble. We're going to schedule you for knee surgery. Half of the people, they would perform the surgery and change where the ligaments were or whatever else and then put them back together. The other half of the people, they would cut their knee open and then sew it back together and not do anything. Strange thing is they found that the results were very similar between those two situations. Whether you actually did something or whether you just cut them open and put them back together, it didn't make a difference. And if you think about it, if you cut somebody's knee open and then sew it back together again, they still need to go through rehab, right? They still have to be able to rest in certain ways and have physical therapy and everything like that because they got their knee cut open. So maybe it was the physical therapy that actually made a difference in their knee treatment. And it was not actually the cutting of the knee and the rearranging of the things. Now, knee surgeries are pretty expensive as far as I understand. They can bring in a lot of money. But if you say to a hospital or a doctor, you know what? They don't work. They need physical therapy. They don't need their knee cut open. Well, they're not going to make as much money that way. So that's a problem. The same thing is true with stents. I don't know if you've ever heard of stents. Stents are things that they put in people's hearts and they open up the vessels in them so that the blood flows better. And there are certain situations, especially very urgent things where people are just about to die. You put the stent in and it works and it makes them better. But if they're not emergency situations and you don't put in a stent, but you treat it with medication or exercise or therapies of various kinds, it might actually be better for them than putting in the stent. But if you give that information to the doctor and say, it's actually better if you don't do the surgery, it's hard for them to not do the thing. Because then the patient says, well, why didn't I get surgery? You know, I don't feel better. You're saying that I can just exercise? Well, I don't want to exercise. I want somebody to cut me open and put a thing in to make me feel better. Well, if you just exercise, it would work a lot better and it'd be a lot less costly. Well, no, let's do the tens of thousands of dollars for this thing, which might not work, as opposed to exercise, medication, or other kinds of therapy. So we have trouble, okay, when we say we're going to cause a change. We're going to make something happen, and then we're going to know whether the thing actually works or whether it doesn't. Because the doing of the thing is going to change the situation. We can't help it. Heisenberg uncertainty principle, if you study physics, tells you that whenever you make something happen, you interfere with it. And that's also true over here. The other problem, though, is over here, if we're just observing things, every situation is really complicated. How do I know that it's the cranberry juice? Maybe it's just the fluid intake. Maybe it's just the kinds of people who like cranberries have a genetic disposition to better health. I don't know. So just observing things, you can't really tell what is the thing that's making the change. But if you make the change, making the change changes the person, changes the situation. So that's another thing that can cause difficulties. All right, so those are the things that I wanted to talk about today as far as what's out there in statistics. So then when we get together next time, then we'll have time maybe for you to ask any questions that you might have and see what else we have going on in chapter 1. So I will plan to see you next time.